I'm Stephen Hardy, Editorial Director of Broadband Technology Report. As cable operators upgrade their infrastructures to meet rising bandwidth demands, the opportunity presents itself to build intelligent networks as well. To discuss this opportunity, I'm here with Hanno Narjus, Senior Vice President of Teleste and CEO of Teleste Intercept, which represents Teleste in the US. Hanno, Teleste has discussed the concept of intelligent networks for some time now. What does the concept mean in practice?
Thanks, Stephen, for asking. And in practice, we are talking about optical nodes and amplifiers in a cable access network. And as we know, traditionally, these network elements have been aligned manually, meaning a cable tech is visiting the site, he has a measurement device, and bunch of plug-in equalizers, attenuators, and manually he's aligning the amplifier levels as needed for the network performance. Now we, with intelligent networks, have automated pretty much all of that. So we have integrated lots of sensors in our network elements, in our amplifiers and nodes. They are measuring tons of parameters, levels, power consumption, etc. And then we have been developing algorithms and software so that the sensor data is then turned automatically to control the levels and other parameters of the network element, and all of that is done automatically. Now, having done all of these electrical adjustments and those measurement capabilities, we can, on top of local work by the cable tech, we can also expose these network elements to remote control, remote monitoring from network operating center. So we have developed a set of network management tools so that these network elements can be remotely monitored, troubleshooted, and controlled from the remote location.
So with that established, what are some of the benefits operators can expect by adopting intelligent network technology?
Sure. So all of those benefits can be described under the banner automation. Recently, when we are talking about automation in this industry, we are describing normally cloud-based orchestrators and fancy software technologies. Now, we have introduced automation already way ahead of these innovations by putting sensors and automation into the network elements themselves. So let me give some benefit examples. First one would be automatic ingress detection and suppression. So we can measure and detect ingress in any coax output port, and if we are detecting ingress, we can automatically suppress it, which will be eliminating the disturbance just to a more limited set of subscribers. So the benefit for the subscribers is improved service availability, and the benefit for the operator is having less truck roll to hunt for the ingress locations. All of this is done automatically. Second example would be doing a split frequency change in the coax network. So the split frequency change is a very simple operation. Service tech visits the site, swaps the diplex filter module, and the amplifier detects, hey, I have now a 200 meg module instead of an 85 meg module. And as an amplifier, I'm automatically adjusting myself to optimal level alignments without any intervention from the cable tech. Again, very fast field operation, very short outage to the subscribers, and a very short truck roll. Third example, power saving. So we are detecting the load that the amplifier or node is having, and typically the amplifier has much more spectrum. For instance, next 1.8 gigahertz spectrum, and only partially it is used for the first years. So the amplifier can detect how much load there actually is, and if the load is not on maximum, we can adjust down the bias current to the gain blocks, and we can reach significant power savings, 20% power saving can be realistically achieved. So that is a third example what operator benefits there can be from this intelligent networks concept.
Finally, in addition to the benefits you just mentioned, what relevance might intelligent networks have to operators' 1.8 gigahertz upgrade plans?
We see that the relevance of intelligent networks concept is even more important. So let's look at downstream and upstream separately. So downstream, with 1.8 gig upgrades, the capacity of the coax system will be limited by the total composite power capability of the amplifier. And with intelligent networks, automatic level adjustment capabilities, we can very accurately keep the levels at the optimum level and with very, very low tolerances, no matter what the temperature variations in the outside plant are. And when the tolerances can be very small, that means that the system can operate much closer to the maximum total composite power capacity of the amplifiers. This in turn gives more gigabits per second. So with the same capex, you get more gigabits per second when you have perfect alignment and stability in your downstream system. So that was the downstream part. For the upstream, let's keep in mind that now the upstream will be extended first to 200 meg, after that 400, maybe beyond. So now the upstream, for the upstream, it is just as important that we can do all the temperature compensations, because now we have much wider spectrum that the upstream has to handle. And with our concept, when the amplifier knows the optimum levels for the downstream, we can, with algorithms and rules, we can also define what are the optimum level settings for the upstream and keep and maintain them very accurately. And again, the benefit is that for the same capex, there is more gigabits per second, now this time from the subscriber towards the network.
Thank you, Hanno. Cable operators are always looking for ways to improve the efficiency and performance of their networks, and as we've just heard, new technologies are coming forward to help assist operators in achieving these goals. For Broadband Technology Report, I'm Stephen Hardy.